The next important thing is the content of the slides, of course, and the vast majority of the slides are going to contain some type of graphic. And so this is the reason why I was asking you to choose your favorite type of graphic. And a majority of you have chosen wisely a pie chart for this kind of information in question 5. We have got parts of a whole. When we have parts of a whole, the recommended type of graphic is always a pie chart, a sector diagram, how it is called. When we have to explain the distribution of a continuous variable, of a numeric variable, box plots or histograms are the ones of choice. And we were speaking of frequencies, it would be a matter of bar graphics. This is one of the first lessons in PPCR. You are completely familiar with this, but there are 3 very important things that you must take into account when elaborating graphics. The first one is correctly identifying each of the axes of the graphic. Why? Look at this graphic here. At this graphic, we have some percentages comparing 2 different time moments. You have moment number 1 on the bars of the left and moment number 2 on the bars of the right. But the issue with this is on the vertical axis, we have in this graphic the number of patients, and in this graphic the percentage. So as you may see, there's a huge difference between the 2 of them. If we are speaking about numbers of patients, we can lead to an overestimation of the size of some of the bars. The representative part on this would be the percentage. It is the count versus the total. You can choose between the 2 of them, but I would always advocate the use of the second one, because using the percentage, you are giving the opportunity to compare between different groups. Instead, if you use the count of patients, the reader is not going to know exactly how the total size of each group is distributed. And so in this second way, you can always put the count at the top of each bar for adding extra information, but identifying always what each axis is referring to, because if not, it can be confusing. This kind of colorful graphs are very useful at some points only. Especially the 3D graphics are very difficult to interpret. As you can see on the top left border of this slide, I cannot fully compare the height of some of the boxes there. I am not fully aware of how they are comparing each other. And if I choose a bidimensional, a 2D graph, I can have a much more precise idea, because I also have these bars that tell me at which point each category is arriving, and I can easily compare. So don't be fooled by the 3D temptations, because 3D graphics are useful only in very selected and very particular situations. The best way to improve this is to imitate. If you read a lot of scientific information, either posters, either papers published in peer-reviewed journals, the best way to make excellent graphics is to see how the very best investigators in the world are doing it and imitating it. One thing is plagiarism, that of course is never tolerated, but another different thing is inspiration. And I think inspiration is one of the best ways to learn, to see how people you admire, people that are very smart and very competent in their fields, are doing their job, and try to imitate and even to criticize and to see, well, I do not like this kind of approach. I'm gonna do it similar, but not exactly in the same way. And that's a very enriching way of learning, I think. For doing good PowerPoint presentations, good posters, and good graphics, it's exactly the same. If you see something that you like, well, you can get inspired and do the same. That's absolutely no problem. No one is gonna get offended. Okay, let's move forward. These are some examples of complicated graphics, but that can offer a huge amount of visual information. On the left, you have a histogram combined with a box plot. I do that a lot when defining important distributions in my scientific production, for example, dealing with age. Age is very important, especially for us that are treating pathology in very elderly patients. So how age is distributed in our sample is very interesting for us to know. And I usually combine both a histogram with a box plot for people to know where the median was located and if there are any significant outliers. Sometimes I choose to make this graphic as you see here. Sometimes I even put the box plot right on top, right over the histogram with a little bit degradation in transparency. In any of the cases, it's very useful to have both of them in the same place. And there's no direct way to do this, neither in Stata, neither in SPSS or in R. My strategy usually is producing the two graphics and then copying the box plot, matching the x-axis, and then modifying it with PowerPoint. I mean, if you have the same scale in both axes, in the box plot and in the histogram, you can easily put one on top of the other one. They're gonna match, the information is gonna be nice and smooth, and it's a good approach for you to improve. On the right, you can see two different pie charts, one on top of the other, as two different rings. This is a comparison of pre-consultation and post-consultation results. As you can see, what this graphic intends to point out is the difference in the red pie, in the red sector of the pie, which was very low in the pre-consulting ring, which is the inner one, and was very high in the post-consultation ring. This kind of information is useful because you can easily appreciate that at first glance. So be creative, inspire, and go ahead. It's easy to produce very high quality graphics. Excel is a very powerful program for doing this. The only thing you have to do is to play with the parameters and it would get the job done without any doubt. If you want to have an extra of professional look in these graphics, you can turn them to black and white, and you can use filling with lines and with dots instead of using colors. Well, that's an interesting option, especially for peer-reviewed journals. In PowerPoint and in posters, probably some color is gonna be nice and the audience is gonna appreciate. And be careful also when you are submitting to peer-reviewed journals with the image quality. The artwork, what means any kind of graphic you are submitting to a peer-reviewed journal, has to meet a particular criteria in terms of resolution to be accepted. So one interesting thing, if your images are marginally missing that margin, is to use some zooming programs that can enhance the resolution of the image without losing quality. I personally use PhotoZoom Pro. It works well. Probably I've been using this for a lot of years, and at this point, there should be some programs that are getting the job done better. For me, this tool works well, especially from CT images. Sometimes we receive CT images from different hospitals that are not exactly at the resolution we want, and we can overcome those limits using this kind of software. It's a good alternative, just for you to know, just in case you find that useful. It can be a good approach. For example, this one on your left, it is your original image, and on the right, we have multiplied by 10 the resolution, and as you can see, it is almost marginally distorted and the perceived clarity is very high. So it can save your day. It can save your day, and it can be a good alternative if you are having issues with the quality of the images. The same things rule out for tables. This table is directly, it is from one of my works, and it is directly copied from the style that the European Journal of Vascular Surgery uses for their publications. So I directly get inspired by that, and I said, well, I'm gonna put my results exactly in the same way, using a very similar lettering and using a very similar approach in terms of the border amount of points of the table, height, and distribution of the content. It is very useful also to take benefit of the space that tables leave in the down part, in the bottom, because you can elucidate a lot of the content you have in there without putting that into the caption. The caption is the small amount of text that the journal is going to ask you to accompany each image or each table. So you can use that for explaining the content of the table or of the image, but you can also put that in the bottom part of your table, and it's going to make the difference in terms of elucidating the content. It is a very good way. For me, it works very good.